Hello guys, how are you? It's YS and I'm here with another paper. It's about KNN2, a new locally adaptive nearest neighbor algorithm based on discrimination class. It's for 2020, sorry. And let's do this. I will explain it very shortly because I have a lot of stuff that I had to do today. You know, the car nearest neighbor, we have a critical on choose adaptive car, and we have a problem about distribution of samples in the nearest of query instance. Let's see it. Okay, if you can see this example, the blue points are most instances near the near of the query instance, and here is two. That's blue points is most uh, class, but here reds are very low, but here reds are just a little less than blue points. But we can see that X2 is belong to red points because the distribution of red points are nearest than blue points to the query instance. Uh, but according to the normal coin, and we can say that X2 belongs to blue points, and that's correct. Okay, but what we should to do that handle this problem? Uh, let's explain this picture. We can just use from the centroid of the class first most class twin most class, and based on the distance between my query point to the distribution of each of the classes, just one and two, not three or else. We can say that x3 is belong to the red. Okay, here is x3 belong to the green, and here belongs to the blue. Okay, so it's so easy. And here we have the algorithm. It has two phases. Mm, let's just explain this shortly. It is x, that is my query example, training set. Max at this paper, max equals 20, but you can make it equal to any number that you wanted. And this threshold is chosen by yourself, and that uses for this phase, stage one, stage of discrimination class, and it's just that I explained on that image, uh, and threshold is this. And say very simple that the ratio between this distance and this distance. Okay, and if those are equal, so you should choose the first most class. But if they're not equal, well, you can choose that is nearest. And for the select the adaptive core according to each input instance. Here is for that stage 2, and that just use from the rank, and ranks are in the table. Have a table here. I don't know where is that now. That was, let's find it here. Okay, here. And that's not a problem because the album is in kind and problems are very easy, as I see. But that easy solutions are have a huge effect on the performance of kind and problem. Okay. Mm, for any car from 1 to car max, that here is 20. Here is 20, yes, I guess. They choose views from this distance between any instance to centroid of any classes, first and twinmost class. And another is the ratio of the number here, the number of instance in the most class, chosen class. And the discrimination is that class that we chose uh, to the car nearest neighbor, that for each car it is different. Okay, for experiments it's used from adding UCI datasets. Those are different situations from uh, classes, dimensions, or other. And they use Coq for cross validation for their experiments. Also, two methods for evaluation. One of them is this number of query to the all instances, and another is trade-off between distributions, most and 20 classification. Okay, and they compare their algorithm with some kind and normal kind, and they said that the algorithm is best. Okay, it's just this. Thank you for watching my video.